This is section 3-2, derivatives of exponential and logarithmic functions. So let's start by looking at the derivative of e to the x, okay? You can see here what the graph of e to the x looks like. It's an exponential growth graph. So let's look at the graph and see what we can get for the derivative by looking at the slope at various points. If we look at the slope, we're going to discover something rather interesting. Notice this first slope line right here, okay? And it crosses e to the x at 0, 1. Well, it just so happens the slope of that is 1, all right? And the next point, the slope is 2.72, and that is at 2.72. And then the next one, the slope is 7.39, and that is at 7.39. So what does this tell us? It tells us basically that the derivative of e to the x is e to the x, which should be fairly simple for you to remember. Well, what about something like e to the u? Okay, what would the derivative of e to the u be? Well, again, we could use our chain rule and remember that derivative of e to the u is e to the u times u prime. So let's look at an example here. Let's say we've got f of x is equal to e to the 3x squared. Well, using our definition up here of what f prime of x is equal to, that's going to be equal to e to the 3x squared, and then the derivative of 3x squared, which is simply 6x. So the derivative of e to the 3x squared is simply e to the 3x squared times 6x. And let's look at another example. Let's say we've got the function is e to the sine x, okay? So that is simply going to be equal to e to the sine x times the derivative of sine x, which is cosine x. Now, instead of having e to the x, what would it be for the derivative of a to the x? Well, the definition of that is a to the x times the natural log of a. So that is the definition of a to the x. Now, but let's look back on what we were just talking about. So e to the x, the derivative of that is simply going to be e to the x times the natural log of e. Well, what's the natural log of e? The natural log of e is simply 1, so therefore we get what we originally had, which was e to the x. All right, so let's look at the chain rule version of this, which is a to the u. So what is the derivative going to be of a to the u? And using chain rule, we can see that the derivative of this is now a to the u times u prime times the natural log of a. So let's look at an example here. Let's say we've got f of x is equal to 3 to the 6x. Well, using the chain rule above, what are we going to get for the derivative? So looking at it in terms of the chain rule, we're going to get the original function, which is 3 to the 6x, times the derivative of the exponent, which is going to be 6, times the natural log of the base, which is 3. So there we have our example in terms of using chain rule. All right, so now let's look at derivative of logs. So let's start with the special case again of f of x is equal to the ln of x. Well, if that's true, then the derivative of ln of x is simply 1 over x. And if we look in terms of the chain rule, instead of having ln of x, let's say we have ln of u. Let's see what the derivative is then using chain rule. And that simply becomes 1 over u times u prime, which is what you pretty much would expect. So let's look at an example here. Let's say we've got f of x is equal to the natural log of 3x plus 2. So using chain rule, how would we get the derivative of that log function? And that simply becomes 1 over 3x plus 2 times the derivative of 3x plus 2, which is 3, okay? So pretty straightforward in terms of using chain rule, how we deal with natural logs. So lastly, let's look at just a general log equation, okay? So that we got the f of x is equal to the log of base a of x. Well, the derivative of that, by definition, is simply going to be 1 over x times 1 over the natural log of whatever the base is, okay? And again, if we go back to our special case where we had the natural log of x, if we use this definition, we're going to have 1 over x times 1 over the natural log of e. Well, the natural log of e is simply 1, so as we stated earlier with the special case, the derivative of natural log of x is simply 1 over x. So if we use chain rule, and we've got the log base a of u, what would the derivative of that be? And that simply comes out to be 1 over u times 1 over the natural log of the base, which is a, times u prime, okay? So let's look at an example here. Let's say we've got log base 2 of the quantity 3x plus 2. The derivative, therefore, would be 1 over 3x plus 2 times 1 over the natural log of the base, which in this case is 2, times u prime, which is the derivative of 3x plus 2, which is 3. So pretty straightforward if you follow the rules.